But what about literal physical dust? Because sometimes the contamination isn't a trace atom or a molecular film. It could be like a giant, by giant I mean like 100 nanometer flake of stainless steel sitting right in the middle of your die. So what do we do then? To find and analyze this physical defect, we use a two-step process. So the first step is optical particle counting, or OPC, which provide high-speed particle detection. Because when we talk about physical particles, our first line of defense is this. The core principle relies on laser light scattering to rapidly scan unpatterned bare wafers ranging from 150 to 300 mm, entirely within a strict Class 10 cleanroom environment. While it is optimized for bare silicon, we can also measure particles on certain thin films upon request. Because optical particle counting is incredibly fast and can generate exact coordinates map of the physical defects, binning them by size and detecting particles down to roughly 80 nanometer. However, it has a major limitation. It is chemically blind in that it tells you an 80 nanometer particle exists in a specific XY coordinate, but it cannot tell you what that particle is made of. That brings us to the second part of the particle equation, which is automated SEM-EDX. To figure out what those particles actually are, so you can fix the root cause, we need to move from purely an optical detection to explicit chemical identification. And this technique brilliantly bridges the gap between physical detection and chemical identification, because we use high-end automated defect review tools to perform a targeted review. Instead of blindly scanning the wafer from scratch, the tool imports the exact coordinate map generated by the optical particle counting tool. The automated scanning electron microscope then drives the stage directly onto those specific defects. And once we lock onto the particles, we reveal what is in it using energy dispersive X-ray spectroscopy, or EDX. So the electron beam excites the particles, revealing its exact elemental fingerprint. This allows us to easily distinguish between a metallic shedding from a robotic arm versus carbon-based organic flake. And finally, the software handles the automated classification by instantly analyzing and categorizing hundreds of particles per hour. This completely transforms blind particle count into an actionable Pareto chart, kind of immediately showing your engineering team which tool components are failing, causing the most severe contamination, and what percentage of contamination is arising from that particular source.